Question 7. The incomes in a certain large population of college teachers have a normal distribution with a mean $60,000, standard deviation $5,000. 4 teachers are selected at random from this population to serve on a salary review committee. What's the probability that their average salary exceeds $65? Okay. So let's draw a picture of the population distribution. Okay. So we know that it's normal, we know the mean, the standard deviation. Okay. So this sketch represents the population distribution. Normal, the mean is 60,000, and the standard deviation is 5,000. Okay. Now, when it starts talking about the sample of 4 teachers, okay, to answer that question, we need to use the sampling distribution. Okay. Now, which sampling distribution do we need to use? Well, it's asking questions about an average, so that would be the sampling distribution of X bar, right? The sample mean or the sample average. All right, so in order for us to sketch the sampling distribution, we got to know a couple things. We got to know its shape, we got to know its center, and we got to know its variability. All right, shape's the easy one. Since the population is already normal, then the sampling distribution will also be approximately normal. All right, the center and variability, we can calculate these things, these values, by referring to a couple formulas on our sheet here. Okay. So we're doing a question about the sample mean X bar. Okay. So the center or mean of that sampling distribution is just equal to mu. So it's the population mean. And its standard deviation is sigma over root n. So that's the population, SD, divided by the square root of the sample size. Okay. All right. So the mean of our sampling distribution is equal to the population mean, which was 60,000. The standard deviation of our sampling distribution is equal to sigma over root n. So that's 5,000 divided by the square root of 4. Okay, remember our sample size here was 4 teachers. Okay, square root of 4 is 2, so that's 5,000 divided by 2, so that's 2,500. Okay, so I don't really need the population distribution right now, so let me just kind of shrink that and move it out of the way, and let's move that work over here. Okay, so let's make a sketch of our sampling distribution. Okay, the shape's approximately normal, so draw yourself a bell curve, label it n for normal, the mean is 60,000, and the standard deviation is 2,500. All right, the question is to find the probability that the average exceeds 65,000. So 65,000 is going to be somewhere over here to the right. 65,000. Exceeds means greater than or equal to, so shade the right tail. All right, from here it's just 2 more calculations. Number 1, standardize, so find the z-score. Number 2, I guess we don't really need to call it a calculation. We use table A to look up the area. All right, so let's take our boundary value, 65,000, minus the mean, divided by the standard deviation, and I think that's going to be 2. All right, 65,000 minus 60,000 is 5,000, and divide that by 2,500, it's exactly 2. 2.00. All right. Now, let's look that up in table A. Highlight here, there we go. It's 9772. Okay, of course this isn't the answer. That's the area of the left or unshaded tail. So to find the other side, we'll just subtract from 1.0228. All right, and that is a perfect match for choice A.